So yes, we are live. Um, yeah, we're live. So hello everyone, welcome to today's session. My name is Mustafa, and with me here today is Anthony. Hello, what's up?
Hello. So thanks for having me,
Hi.
Mustafa.
Yeah, it's nice to be here. So today's session is mostly going to be question and answers. Uh, we are going to be discussing about experiences, software engineering in general, and all the amazing things Anthony has built, including the one you can see on your screen right now, which is API Toolkit. So before we dive into the entire thing, let's just introduce ourselves. Um, my name is Mustafa, in case you don't know me. Uh, I am a software engineer and developer educator. Currently, I create technical content. You may see some of them at LinkedIn Learning, Pluralsight, and a host of other places like that. Yeah, that's me. Anthony, who are you?
So you start with the hard questions. Eh? Okay, so my name is Anthony Alaribe. I'm a developer. I'm very interested in technology, in a lot of things. I like the intersection between maths and software engineering. And yeah, I've been a developer for the last 15 years, thereabout. I started I started as a teenager actually. So um, and yeah, that's basically who I am. I'm Nigerian. I grew up in Calabar, an amazing town in southern Nigeria. I don't know what else to add. You can give me ideas.
All right. Sorry for that. Just want to be sure of something. All right, let's get to it. So,
Okay. It took me backstage for some reason.
okay. So, are you with me now?
Yes. Can you hear me?
Yeah, I can hear you. I can hear you. So, I think we should start from this week and your your popular tweet about that assembly language, like
Ah, we were. It's called we were. So
um,
Lua is it's a stack based and array based programming language, and
okay.
I find it interesting. So a lot of people don't know, but there was a time where a language called APL was super popular worldwide. And APL is this language that is written using some characters. It's written. They have some specific unique characters that are unique to APL. And before now, where everyone has all of these big computers. Okay, maybe I give you the full history of APL. So APL actually started not as a programming language, but as a notation. So there was the author Ken Iverson. He has this very popular paper called um, notation as a tool of thought. So basically, if you want to think and express very complex ideas, how notation and just stepping away from all the big grammar and all the words can help you express the points you're trying to make better. And he won the Turing Award for that paper, and that was the I think that is a big background behind a lot of the array programming languages right now. And Wiwa is just one language in that tradition. So there was a time also when um, we used to have more time sharing computers, which is basically you had this thin client. So you would have the proper machine, maybe in your university or in somewhere, and then everyone is sharing time on that big mainframe computer.
Yeah,
And
that I'm
then
familiar
they
with
would charge you per character that you're sending over the network.
that.
So given that when they're charging you per character, obviously you probably don't want to write Java and, and pay
At
per
all.
character for all the Java. So API was very popular around that time among certain niches, but also its background as a tool for thinking, for expressing complex ideas, is also very good. Also, if you think about maths, I mean, anything you do in math, you can also write it in pure English, right? You don't need to, instead of writing plus as plus sign, you can write plus. But we prefer to write math with the math characters because it's shorter, it makes us think about the bigger picture and express our ideas very accurately. So that's kind of the benefit of this kind of this having unique
I can
yeah
see it.
you
So
know.
how long did it take you to um what's the word there, to be able to write this? What's the learning curve like?
So I'm actually still learning we were so so we were something, maybe you should go to the website actually. So it's not
Okay.
it's not yeah, wiwa.org, uiua.org. So if you go to documentation, I think, scroll down. So now you can see all of the characters that Wiwa
Oh,
introduces. So if you notice that it's not that many and they're not that strange. So a lot of them
this
are
this
things you
looks
already know.
familiar.
You already know square roots. You
Yeah.
already know plus or minus sign. You know negation. You're already using a lot of these things in maths. So it's not like, yes, there might be some keywords or some glyphs that are newer, but it's just a finite set. It's like maybe 30 or so, maybe new characters that you just immediately what they look like. You don't even see the characters anymore because you're reading it with the word, because they have names. So you would not see the square box anymore. You'll see table, you know things like that. So it's not like a lot of things to see that you have to do.
It looks daunting at first, but when you now see that there are limited characters to it, it makes more sense and it looks much more
Mhm.
interesting
Now
at the
imagine
end.
that with that limited
Yeah.
character set, you can build a lot of amazing things. So you learn a few things, but now you have these super powerful tools in your tool belt that you can do anything crazy.
Yeah, very, very interesting. It's all right. Okay. The first time I met you, not necessarily met, I heard you talk. Was about 3 4 years ago. You were on a session with Perfect, and you guys were talking about. Okay, you guys were breaking down. What's it called? So open source tools. Then you
Mm.
were talking something about Haskell or something. So it's interesting coming from that till this time. So can you just take us through like your trajectory, like your career trajectory over time, so that we can get a good sense of it? And how did you come so edgy?
Okay. So I started programming. So in Nigeria, we have this JS1, JS2, JS3, then SS1, SS2, SS3, basically our equivalent of high school. And between the JSS classes and the SSS classes, we have this break because you write these big exams and you have a break before you go into senior secondary. So it was very common at the time that you use that break to learn something, because your parents want to get rid of you. They don't want you to leave the house to be at home, so they'll send you somewhere to learn whatever. And for me, at the time, I was already very interested in computers because my dad had this desktop computer that he would guard. And so we don't break it, so he would guard it so much. And I was like, okay, so if I go and take these classes, would you finally allow me to use this computer? At least. And I took the classes, and the classes was basically to learn. Microsoft package, Microsoft Docs, PowerPoint, Excel, things like that, which I was already familiar with at the time. So I was more bored during the classes than not, because I had, of course, there was a lot more to learn, and I learned quite a lot, but it was a bit boring. But thankfully, the place I was studying, called AfriHub at the time, they had internet. And internet was this. I mean, this was not. This was maybe 2007 or 2008. So internet was not like something you had at home at the time. And being a young, early teens boy, it was really nice to just be in this computer school places. As basically, if you come before your classes, they let you use any computer, and the computers had internet. So we would go like super early and use the internet all day. And after class, we would stay there till night, and it was a little bit of an addiction. But around that time, on top of playing games, and learning how to cheat in GTA, Grand Theft Auto, and I also, got introduced a little bit to web technologies, and I wanted to build some of those websites. I wanted to build some of those things. So fast forward, after this program, I was no longer in this school. I don't have access to the internet anymore, except going to the cyber cafe to learn. I wanted to learn. I wanted to build a website. I wanted to build something, and I had to figure it out the hard way, which was on a Windows computer at the time. I think it was F1. When you press F1 on your computer, it brings up this help experience that had a lot of documentation and written stuff in all Microsoft computers at the time. And through that, I learned about, I think I learned VB scripts, and then I learned JScript, and I used those to make very silly viruses, which I would send to my friend USA at the time. They're not really properly viruses, but just annoying pieces of
Malicious in
software.
their sense.
Yeah. So I would give him this thing, maybe like an image or something, and when he opens it on his computer, it would like start writing "I am a fool, I am a fool" in any text box anywhere, or it will start popping up the CD drive. So to pop up the CD drive, you close it to pop it up again. So I used to have fun making all those silly things, and I took it the next step to actually make that website that I wanted to make. And the only material on outside of the internet, because I didn't have the internet, the only materials there was about the IIS. I don't remember what IIS is acronym for, but it's just like the equivalent of Apache, but for Windows or Microsoft at the time. And I had to learn ASP. So I spent a lot of time building my project, my pet project in ASP and VB, Visual Basic and ASP, only for me to build it and want to put it online. Then I realized, you need licenses for Microsoft, and also ASP is already becoming outdated. There is now ASP.NET. So, and those are two different things. So I researched more. I was not going to pay any money for any license. So I discovered PHP. I had an interesting career, having fun and building things with PHP. Learned WordPress along the way. Then got into Python, did some things in Python, Django. I think we had a hackathon at the time. I met interesting people. In all of this time, this was around the time before you get into university. So this is in the space of 3 years. So by the time I got into university, I was already doing some Python. And by my first year, I think we did a hackathon. And then I learned Go, and we did this NASA Space Apps hackathon, which my team came third in Cross River State. And so I was, since then I'd been writing Go, and unfortunately forcing Go into a lot of the small startups in Calabar then that want to build something. I'm telling them, you have to write it in Go, even though there was no Go engineers in Calabar that they would hire if they had to hire someone after me. But it also meant I got to learn, and I got to do things I enjoyed. and I kind of stuck with Go for a very long time, so closer to 10 years, because the first major projects that I built for a client or like freelance was around 2013 in Go, and yeah, and I was doing Go right up until even now. I still do Go, to be honest. um, but then at my previous somewhere like 2 jobs ago, I've always been like doing other languages anyway on the side, but I got more interested in Rust, and then my last job was in Rust especially. But somewhere in between, I was also interested in Haskell. And so when the time came to build this my startup APIToolKit, Haskell was it was a no-brainer. And it was a no-brainer because the first version of APIToolKit, I wrote it in Go. And in fact, we even had a Golang, we were on the Golang podcast when I was talking about like APIToolKit and what I was building. So the first version was in Go. But then I needed to implement a query language for querying and exploring the logs in your server. It's very painful to write a language like this in Go. I was already doing like writing hundreds of lines of code. And then I said, okay, I won't swear, but I went to Haskell and I wrote this same code in like 160 lines of well-documented Haskell code. And I never went back. I just kept adding more features in the Go side. A lot of things were just easier to do in the Haskell side than in Go. So while Go was just amazing for performance, when it came to just developer productivity and expressivity, it was just a no-brainer to build in Haskell. So along the way, I've always been interested in languages, in how developers can be very productive. So that exposed me to things like APL and BQN and Lisp and other languages that might not be the most popular.
So, am I right to think in the nearest future you're going to be designing your own language?
I've actually written I've actually written toy languages. I
Oh,
don't have a strong interest in building a full language. But what I can announce is that I am working on a language that compiles to SQL. Basically, I think SQL is great. The relational model is amazing and it works. But um, from the developer perspective, especially if you're doing anything analytical, um, we would like to have a better experience. I would like
yeah.
to I would like to say, so if you notice, a lot of the work we do is transformation. We're transforming data from one form to another. So I would like to have a kind of a type or a schema, but a type that is, I don't want to say dependent types. If you've heard of dependent types, it's a branch of computer science, but it's basically where types can depend on values. And I think a lot of the work we do on our databases is transforming. Let's say you have a table of users. You have a username and you have user first name and you have user last name. When you are returning it to your customer, you want to return full name, which is
Yeah.
first name space last name
It's last name.
together. So that field is dependent on the other fields on the row. So why can't we express that in the schema of the database or in the type level? So that when you just query it, you have some fields that are dependent, they are just basic calculations or transformations. And so it will be like a kind of query language and a schema language of some sort. But it's not a
Like
full
GraphQL.
programming language because it's only for database.
Yeah, I get. Makes sense. Makes sense. All right, let's talk about API 2K for a while. So my own experiences with APIs um, on the last scale was mostly as a developer advocate, and we used a lot of tools to manage our services, and our merchants will use them. So I am wondering, if I were to come to you, let's start. If I were to come to you as someone who handles a fintech API, how do you simplify my life?
So I actually have an article that I'm writing right now. It's on my screen right now. And the
Uh,
title of this article is,
you want to share?
it's still a work in progress, so maybe I won't share yet, but I'm going to share the link on Twitter.
Okay.
But the title of the article is, what do you do about the high shege per minute you get with API integration? So for those who are not Nigerians, shege is basically a Nigerian term, and it means it's tough to explain, but when you have unpleasant situations or circumstances, just anything that is very unpleasant, and in Nigeria, I would say anything that is showing you pepper, but something unpleasant. So, what do you do about the high shege per minute you get from your API integrations? And I'm basically telling the story of my experience working in fintech. And I was part of the, Perfect. So I and Perfect worked together when the foundational team building Opera Pay in Nigeria and in Africa. But since then, I've also I have a lot of friends who are in the financial tech space, and I unfortunately have to give advice sometimes or consult a little bit. And it's a pile of cards all the way down. I remember in Opera, we wanted to, first of all, wanted to get to market fast. So we said, okay, we're going to use Flutter Wave APIs as the, just for a start, and it's expensive, but we'll bear the cost just so we can roll out something to the users early on. We integrated Flutter Wave. Soon we were having, I don't remember the error rates, but we're having substantial error rates. And you don't want to have error rates. You don't want, the customers you're trying to get, their transactions are failing in their first try. So we said, okay, fallbacks. We're going to have the next giant, the next fallback. We're going to have Paystack. So now we have Flutter Wave. When Flutter Wave fails, we fall down to Paystack. Paystack was now still failing on top, even in the backup position. So what do we do? I think we had many levels of fallback. I think we had Zenith Bank direct connection at some point, and then eventually we added NIPS direct.
Yeah.
I worked on integrating NIPS. NIPS is the national interbank settlement system. Then at some point we had MasterCard somewhere. So we had all these levels of fallbacks, because none of them was reliable. We're always just getting shaggy from someone, and at sometimes everything down the line would be failing. And when you have a system like this, it's not just that your dependencies are failing. There are good reasons why they might be failing. The problem is that you never know if your users complaint is because of you or it's because of who you depend on. Right. So you want to be able to check. Sometimes it's something silly. You might have it, let's say you depend on someone and they just push a breaking change without telling you beforehand. So they just change some field. Some field used to be a text, and now it's a number. And now everything is breaking for you, and you have to rush and fix it and update to the new API, which they did not announce before. Or sometimes maybe maybe it's not even your dependencies. Maybe it's even just you. Let's say you hired a new. Okay, before the hiring, let's say you have a library that you use for your dates. So you return a string formatted date to your customers. Now that library, they were using the US date formats in the past. And now maybe it's been going on for some months, and someone said the US date format is not standard enough. We need to use something standard. Let's move to EU date format. And they had some arguments, and eventually they moved to the EU date format, and they pushed the breaking change. They announced it in their
developer
in the
community
releases,
on Slack.
breaking change, but you don't read these announcements. So now your API is returning, before it was returning US dates as a string. Now it's returning EU dates as a string. In your back-end perspective, nothing has broken, nothing has changed. There is no failure, there is no error logged. But from your customer's perspective, everything is broken. So much is going wrong. The analytics is broken. Everything is gone bad. How can you detect these kind of things so that your customers do not have to even be the ones that are coming to complain and knocking at your door? So those are the kind of problems that I set out to solve. And I've faced them not just in the financial sector. In one of my previous jobs, I worked in a food delivery company in Berlin, in Germany. And one of the first big problems we faced, we lost thousands of orders. And we lost thousands of orders basically because one field was missing. Just one field was missing. And I really wanted to solve these problems and give developers tools so that they can detect these issues quickly. And and that's what brought us to where we are now in APIToolKit.
Makes sense. Pretty interesting what you are doing. Amazing job. So what will you say is the biggest challenge you have faced building this APIToolKit right now?
Maybe before I answer that question, you tell me, how do you guys solve these problems that I mentioned at the moment?
So the primary thing is we are the one providing, so others are building on our service, right? So our major issue is the different ways in which these people want to consume our APIs, and how we tackle each of them, right? We don't provide any analytics for simplicity's sake, or so there's no analytics for them. When they are onboarding, so we have to environments. They do all their development in a test environment, then they move to production. And then, so in the test environment, they need to export all their data to production. And then we have to start the entire process all over again. And because the production is not well mocked to test, right? It means it's not one-to-one. All the features that are available in test that is available in production, right? So we are always it's like you're building an entire new thing in the new environment again for them as they are connecting to production and going live on the system. And then but it's interesting. It's a lot of battle and firefighting almost every day.
Interesting. But how do you right now, since you are the ones providing these APIs, like, do you worry about breaking changes to your customers? Do you give them any
Obviously, many times. So there is this. Okay, let me. So we used to have this thing where, so we have the POS channel, offline channel, we have the web channel, and we have the what other channel do we have? Okay, we have virtual cards and stuff. But I think but this particular issue was on the POS. People cannot charge on the POS for whatever reason. I can't remember the particular reason now. But the card wasn't working on our POS. So so people, we had about maybe 10, 20 million people. They can't withdraw offline. So the engineer that was assigned to the task, what he had to do was our online channel, our web channel, was now routed back to the POS. So when the step that would take you two things, one, two, and then you have gotten your offline payment and you are off. Then on our own end, we in the company know that you have to do 5, 6, 7 things now to get to the web environment so that our users can now use it as the offline payment. In the
Yeah.
meantime, while we fix the offline payment stuff, our issue was now then, one, we need to pass this to all the people who are currently consuming our service. We also need to pass it to our merchants who have the physical device and train them on how to use this new web channel that is going to be phased out in 1 month so that they can go back to the old way again. So I don't know. It's a lot of
What was broken, and why was it difficult to fix the actual issue that was broken?
one was the system itself. It was an old system of about maybe 10 years. So people were afraid to touch the code. That's one.
I know. I know that feeling. It's too common.
People were, because one is, though the issue is this thing is broken. We all know it's broken. But you are not sure if you touch this, another thing will break, right? So people were afraid, number one, to touch anything. So what the engineer did, because I wasn't the one in charge, was I think he eventually brought down everything. We did maintenance for that period of time, and then tweaked out everything. I wasn't sure. No, it's earlier in the year. Anyway, that's that on that.
So
Um,
it's so common that fear, because as developers we say, oh, every system should be very well tested. You should test every endpoint. But in practice, if you do a survey of companies, it's not easy because you are trying to balance features. The business continues asking for new features, and you're balancing it with your technical depth and the available team size. So the test ends up suffering until the developer who wrote the feature leaves the company, and now no one really knows how it works.
yeah. So now the system was built about 10 years ago. It works. It works perfectly. But then the new engineers that are on team are probably 6 months into the team.
Yeah, they
So they are
don't.
still getting familiar with the entire setup.
So those are the kind of problems that APIToolKit actually solves, because we have this change detection and anomaly detection on your API layer. So it's like having a monkey, or a very smart monkey, that is sitting down and is looking at each API call that every user is doing, and he's learning how it looks. So
Oh,
that by doing that, if,
nice.
if a new developer touches some code that he does not understand and he breaks something, then there will be a change from the perspective of the user. So this monkey would see, this does not look like how it was looking yesterday. Maybe this field used to be a UUID, and now all of a sudden it's a name, or it's an empty string. What is going on? You know. So it's like the test that you should have had, but you did not write.
So now, when this monkey detects this anomaly here, it alerts the consuming company, right? And they are aware of this change.
No,
Yeah.
no, no. It alerts the provider.
Oh, it alerts the provider.
Yeah, it
Oh,
alerts the person who integrated. But if you are consuming another API, you can also integrate it on your side. And if the API that you are calling is broken, then you too would also be alerted. So it's whoever integrates it is the one who gets alerted, basically.
okay. Makes sense. Makes sense. Uh, I think we used to have. I've forgotten the tool. We used to have a tool we paid a lot of money for that allows us to track all the logs of our API calls. All right, let's get back to it. One particular interesting thing is if you if I am a consumer and I need to consume a lot of APIs
Yes.
to be able to provide my service, how how can I track all of them in one service? Is that possible with APIToolKit?
Yeah. So we have these clients. I don't know if I should show you. Let me show you. Can I show my screen?
Yeah, you can. Just you can see present at the bottom of the screen.
All right. Let me just open a new environment that I can share. All right. Tell me you can see can you see?
Yeah, it's coming up. Yeah, I can see it.
Okay, maybe I'll go into one of the SDKs. So, well, if you use something like Express, we have like a middleware that would just like monitor and stream some of the traffic for analysis. But we also have a client. There's a lot of things here. So we have clients. For example, this one is for Axios. If you use Axios on Next.js, Node.js. So if you use Axios, so it's basically a wrapper that you can wrap around your existing client. This is optional, but this can help you give it a name or give it more information. And then you just make a request. So when you do this, we're able to track the outgoing calls that you're making. And then when you go to the APIToolKit system, let me open a dashboard, and then I can show. And then when you go to APIToolKit, like here, so when you come to APIToolKit, like here, for example, you can now see, you can see basically, if you go to endpoints, you can see all the endpoints that you have. So we detect all the endpoints automatically. And then you can, for example, go into any particular endpoint, see the documentation that so for example, this prices endpoint, these are the different kinds of responses or the different structures that it returns. So for example, here it returns a list, and here it returns a lot of stuff. So you can see all the responses and the fields, etc. And then we also detect like the changes that, for example, if there's a new field, or if there was some field that was updated and then someone gets notified, and then you can like investigate it. Just taking a second. And then you can look at it and investigate it and see the requests that had this new field, for example. But I think what a lot of people even like to do the most is that they like to just explore the requests that their users and their customers are already making. For example, this one had 404. So this one's 304. So just being able to just explore and see, okay, what are my customers doing? And which ones are failing, which requests are failing. So for example, if I want to find the failing request, I could maybe search by the status code. Where's status code in here? Yeah, so now this filters out the ones that are just 3 or 4. So if I want to find all the requests that are more than 3 or 4, all the status codes, so that would basically be the erroring request, and you can see all the 404s, etc. Let me see the ones that are not 404. That's equals 404. Okay, so now we're seeing 403, but you get the gist. So
Yeah,
by doing this, so here you see this is an incoming request, but you can also see the same thing, but for requests that are outgoing. For example, if you're calling Flutterwave, or if you're calling someone else. And then, something that people also like is being able to get, for example, Swagger just by automatically. Let me see if I can find a good example. So, for example, being able to just get like Swagger that no one had to write. You get what I mean?
Yeah.
Imagine not having to write your Swagger, and it's always going to be correct and always going to be accurate because it's based on the actual production you have.
And that is like the most the thing I've been waiting for so far.
Yeah,
Because
because
so does this generate in multiple languages? Like can it generate like an SDK or documentation in PHP, Node.js kind
yes,
of stuff?
yeah, we support a lot of languages: PHP, JavaScript, Python, Go, Haskell, .NET, Java. So, but obviously, we don't support every single language under the sun because we're trying to focus on the things that people people ask for. So if you use something that we don't have, then just shoot me a message and it will probably just take a weekend and you would have it. So anyway, this is API Toolkit.
Yeah.
You have to see all the endpoints that you have. Being able to explore, track all those changes, track everything that broke, so you can fix it.
It's all right. Someone on the chat session is asking what your best stack is.
I don't even know, to be honest. I like a lot of things, and I end up liking things for different reasons. So it becomes a very hard question to answer. I really like Go because Go is very simple. And if I build a technology in Go, it means I can onboard new engineers very quickly to that project. Usually they don't, maybe it takes them a week or something and they're already pushing code to production. And the code Go is pretty fast, so you don't think much. But I also really like Rust. And I like Rust because sometimes I find Go to be too simplistic. You end up writing a lot of code to do simple stuff, because it's things that in other languages would have been a library or a function call. You're now writing it like to do sets is something in a set. You'll be using a hash map in Go. But I like Rust because it has all those expressive, it's very nice, those high level features, but it's also fast and even faster than Go. Unfortunately, Rust, if I build a project in Rust, I will not expect my engineers to onboard and learn Rust in 2 days and push to production because Rust will give you a headache. In the words of someone on Twitter, they said Rust will show you shaky. But I like Haskell now a lot more. APIToolKit is built in Haskell. I like Haskell because I find it to be somewhere in the middle. So Rust is very heavily inspired by Haskell. Rust traits are basically Haskell type classes, but maybe modernized or something. Because Haskell is like a 30-year-old language. It's been around for a long time. So a lot of languages keep stealing and borrowing things from Haskell. So I like that Haskell is a middle ground. They have all this very high level way of thinking and writing your code, but you still get Go level performance. So the performance is in the level of Go, and usually for a lot of projects, that's what you need really. So here we're really written in Haskell, so and we don't have performance problems, at least not yet.
All right. I think we should end on this end so that you can catch your shift. Someone final question before we go. Someone is asking if you love to see Haskell plus HTML stack.
I
Are you
can
using
show.
it?
Yes, I can show. Let me show you something here since we are already looking at this page. This page is basically HTMX, and the easiest way to show is by, let's zoom in, and then I'll show you. So you see this load more function.
Yeah.
This load more function works because of HTMX. So there is HTMX works through attributes, HTML attributes. So I add this attribute hx get, and I give it a URL. So I'm basically telling it anytime someone clicks on load more, hit this URL, and whatever you get, replace me with it. So that's what this outer HTML is. So it's going to delete this button, this A, and then to replace it with the HTML that comes. And you see this HTMX indicator. It's just basically going to show this indicator while it's loading, which is just a CSV. And let's see that in action now. If I click on load more, boom. So you see the indicator, and now it's been replaced, and it happens super fast, so super fast. So imagine being able to implement pagination, this infinite scroll, with one line, literally like 2 attributes. And in Haskell, doing this is super simple. Let me make sure I don't have anything that's super confidential. Then I can show code a little bit. Okay. So I think everything is clear.
Let me know when you need to run. All right.
Yes, I'll be running like. Yeah, that's okay. I think 10 minutes max. Okay, so I want to show some code. So let's go to that log explorer page and let's look for that load more. So this is that load more that we're looking at. So this is HTML, but it's using a DSL. A DSL is a domain-specific language for HTML, where every HTML element is basically a function in Haskell. So we just have the the anchor tag, and then we have all the attributes in this list. And then we have the child. So you see the load more, and you see the button hx get, the URL that it's gonna get, which is the next URL. And when we go to this next URL, so you see the API log. This is the function that handles the request. And in here, when we're handling it, we're basically checking the headers. So if the request is a HTMX request, that HX request, true, then it means we don't want to return the entire page. We want to return only that stop page. So we return only the rows, log item rows, compared to if it's not HTMX, then we return the entire page with the rest of the body's wrapper. Make sense? So it's like everything is just a function, so it's easy to use the function in many places. And this function represents the rows that you see in the log explorer. And so that is it. It's a very simple stack. And which is why I enjoy it, because there's really, I think there is no magic. I'm just writing HTML and putting in some attributes. And I like Haskell for this syntax, because any element I'm doing is basically a function. So instead of having components like in JSX, I can have all these small functions that are basically HTML code. So this is a function in Haskell, and this is the types, and this is the names. So request DOM, this is the argument name. This is the type. Modal is Boolean, and then all of this is just. So by doing, it's almost like JSX for those that write React, because we can mix in some logic into the templating, and we do this easily because it's just Haskell code. It's just, you're just writing Haskell. It's not like you have a template language and you're trying to, like, I don't know, do a lot of stuff.
Combine multiple stuff together. Yeah. All right. I think we are going to stop here for now. Thank you very much for taking your time and sharing your experiences and your code and your work with us. It's been really nice hosting you today. Thank you also everyone who joined today's session. All your questions and comments. Really nice to have you here. Please catch Anthony on Twitter for more questions or any other thing you have for him. Thank you very much, Anthony.
Thanks for having me, Mustafa. Thanks, Max and Excel and pretty much everyone who asked questions. I had a lot of fun, and so thanks a lot for having me today.